Hello, everyone. I'm Rafe Lawson, Executive Director of the Profitability Analytics Center of Excellence. For those, or PACE, for those of you who are not familiar with PACE, we're a group of volunteer professionals dedicated to helping organizations make better, more informed decisions through the use of analytics and causal business models. Membership in PACE is free. We offer a tremendous amount of resources, including webinars such as this, podcasts, articles, ebooks, and interest groups, and much more. So if you like this webinar or interested in find out more about PACE, please go to our website, profitability-analytics.org. I'm excited today to host this webinar with Chris Andrassy, who's co-founder and CEO of Astral Insights, which is a business intelligence firm using AI to build smarter, faster, more resilient supply chains. We all know this is a hot issue in finance and accounting and supply chain management today, and I'm eagerly looking forward to learn about the insights Chris is sharing today. So without further ado, Chris, please take it away. By the way, this webinar is being recorded, so please keep your microphone muted and your camera off. We will be answering questions at the end, so feel free to put questions in the chat feature as we go along. So having said that, Chris, please take it away.
Thank you, Rafe, and thank you, Toby, for hosting me at this great session. First webinar of 2025, and we will jump right in. So really, we're focusing on what is enterprise performance management, and specifically as it pertains to finance and procurement, look like in the age of AI and advanced analytics. So we'll talk through the old approach, what we're seeing as emerging technologies that are enabling faster, more resilient performance, and then ultimately we'll leave some time for some practical examples. We'll actually walk through a demo. And as Rafe mentioned, questions are welcome throughout. And at the end, we'll try to leave at least 15, maybe 20 minutes to go in to understand what you guys are curious about and have more of an open discussion. So we'll first focus on traditional EPM and some potential drawbacks with how individuals are using business intelligence and analytics as part of their EPM efforts, specifically around continuous monitoring of performance and being able to take corrective action if there's some sort of an operational issue or disruption. Then we'll talk about how proactive EPM, using technology such as AI and analytics, actually enables a more proactive, effective approach. We'll talk about specifically where AI fits in and demystifying what's actually AI versus what maybe isn't actually AI. We'll talk about some practical use cases. And then, like I said, we'll go into that open Q&A. So firstly, the issue that we see quite frequently with the way traditional EPM is run, number one, from a process perspective, is that it's typically siloed and run through the finance function. Now, naturally, there are some advantages to that, but ultimately, it inhibits collaboration with other functions, such as procurement, supply chain, other operational functions, even sales and marketing, who also need that finger on the pulse of how they're doing in the organization, how their day-to-day performance actually affects that balanced scorecard, affects those high-level metrics that a company set for EPM. And often another consequence of this is that the reports that they generate, the dashboards they're creating, are one size fits all. They're not personalized to each individual, whether it's level of seniority that's different or function that's different. And so oftentimes they're not quite actionable. They're not as useful as they could be. Another piece is that they're inherently backward looking. A lot of those dashboards and reports, they describe trends, they describe patterns, they describe those KPIs, but a lot of times, by the time you look at it, it's already happened. And so the response is naturally late. If there's a delayed order, there's an issue with a materials cost or one of your suppliers, oftentimes you don't actually get to understand that there was an issue until after the fact. And in some cases, we've seen it's even weeks after the fact, depending on how these reports are created. And lastly, it's just not as efficient as it could be. A lot of times organizations have FP&A analysts or BI analysts, a large team who are manually building out these reports, aggregating data, and actually spending a lot of time that could be spent on more strategic decision making. So those are some issues. And to keep it interactive, I'd be curious if anyone wants to put in the chat from a scale of 1 to 10, how well you feel that your organization executes EPM. How well can you actually manage performance? How well do you have a good finger on the pulse of how well your function's doing and your organization's doing against its goals? So you can just toss that right in the chat as we go through. Now, in terms of contrasting that with proactive EPM, as we're calling it, this approach is inherently collaborative and cross-functional. So we're providing information to every function equally with the understanding that they each want to see different information with respect to their own function. And instead of backward-looking, it's inherently forward-looking. We're using tools like predictive analytics and AI, as we'll get into in a moment, to actually anticipate operational disruptions, whether that's with suppliers, with production lines, with customers, whatever the case may be, being able to get ahead and proactively mitigate those issues before they happen. We're managing by exception rather than looking at trends and information and dashboards for the sake of it. We're really looking at where are those major spikes in cost? Where are those major issues with delivery dates that need to be tended to? And to actually get to those exceptions, we're automating the creation of those insights. So instead of having a team that's manually collecting data, building reports, we're actually automating the vast majority of that. And the last component, we're also focused on this idea of a feedback loop. So we're going to anticipate or try to predict some sort of an operational issue. And then we're going to quickly understand how well we resolved it. What did we do right? Maybe what did we do wrong? And then we're going to feed that back into a system to continuously improve. And so we will start talking about that on a more practical level in a couple slides. Now, what does this actually look like in practice? It's a concept we're calling embedded intelligence. And you'll see this concept popping up in a few different articles, a few different companies. But the idea is instead of having to look at an Excel spreadsheet or look at a business intelligence report, I can have information that immediately comes right to my fingertips, whether I'm on an iPhone, as you see, whether I'm using Microsoft Teams in Outlook, having information generated and displayed right to me when I need it. If I'm on the procurement side and I'm having an issue with a delay in a major PO, well, I'll get that information sent right to me and be able to take some sort of corrective action without having to monitor a dashboard. And we talk a lot about this concept of supply chain 360, but this really applies across the entire operational footprint of a company, being able to have that continuous monitoring of performance and then being able to send out these proactive notifications through various platforms that you're already familiar with. So now we'll get into how AI specifically fits in. How do we actually create that world where you have information being given to you by a system automatically? The first thing is that we don't start with AI. There's so many technologies out there. We're hearing a lot on LinkedIn and everywhere else that 2025 is the year of AI agents. And certainly there is power in LLMs and agents and generative AI, but we don't want to be a solution searching for a problem. We don't want to spin our wheels. We don't want to take on unnecessary large initiatives if we don't have to. All that to say, instead of starting with data and technology, what we see be most successful is starting with the business outcomes. So do we not have all the information we need to measure, let's say, supplier risk, or to understand our financials at a granular line item level on the GL? But it's a particular business outcome that we're actually aiming towards, understanding what performance increase we need, what are we not getting? And then lastly, we're going to work backwards and say, okay, what tools do I have in my toolbox that can actually get me there? And sometimes the answer is AI. Sometimes the answer is predictive analytics. Sometimes the answer might be simple arithmetic. It might be something that can be done very simply. So by starting with the outcomes first, we're de-risking any sort of new technology or new project we're using and making sure that what we're doing is going to directly impact the business and not just chase trends effectively. And then when we talk about AI, you probably hear the term thrown out a lot, and it's used pretty loosely now. But really, there's 5 categories of things that we sometimes see described as AI. From the left to the right, you'll see more simple on the left, which is robotic process automation, or RPA, which is used more for automation of basic repetitive processes, more of those if-then type process flows. Maybe it's for data entry or simple update to a financial projection or a budget, for example. Then we get into predictive analytics used for more sophisticated financial forecasting, perhaps for demand forecasting, so we can sense changes in environmental factors that might affect how our customers are purchasing our product, for example. Then getting into optimization, where we have maybe a clear-cut outcome. Maybe we want to understand which orders should we fulfill for our customers and in what order under some sort of inventory constraint. Maybe there's a shortage of a key input material, and we want to understand what the proper order should be to maximize either profit or maximize customer satisfaction, as an example. That really falls under optimization and simulation, which isn't technically AI, but you'll often hear this described as AI. And then the last piece, of course, LLMs over the past 2 years have become very popular applications to interpret and generate text. Can also be used to take information that was traditionally numerical or presented in a dashboard or a report and turn it into very intuitive language. And then lastly, as we head into 2025 and beyond, we're starting to see true production applications of what are called AI agentic systems. And what really makes something an agent versus just a model, or maybe even just RPA, like we talked about, is that it's making decisions under uncertainty. It's able to truly make decisions by itself and act autonomously. So if it can't do that, not technically an agent. If it can do that, that is an agentic system. And then I wanted to break this down because as we get into these practical applications and some of the demos, oftentimes we're using multiple of these or even all of these in conjunction to solve a problem. And so it's difficult to know exactly what technology to use until you start with that business outcome. So it really is critical as we have more and more tools and there's more hype out there around AI to really focus on what you're trying to achieve from a business perspective, and then understanding which of these 5 tools might be appropriate for the job. At a high level, putting this all together, we talk about what a technology architecture would look like for this proactive EPM. And essentially, there's 4 levels. So at the top is that concept of embedded intelligence, those automated insights that are being sent to different decision makers, whether it's an executive who only wants to see key deviation from trends, or maybe it's an FP&A analyst, it's a buyer on the procurement team, et cetera. They're getting information that's tailored and curated just for them. Underneath that, we have the AI and analytics layer. And that's where we're doing all of the automation, the calculation, the predictions that are then filtered up to the users in that top layer. And then really what makes it all possible is a concept of a data fabric. And I'm sure many of your organizations have data warehouses or concepts like this, very similar concept that we're able to integrate data, both from ERP, internal systems, but also sometimes external information that'll come into play. Maybe there's a major hurricane or a weather event that's going to affect our suppliers and create a delay. Maybe there's some geopolitical issues that are going to affect demand for our product in a particular region of the world. Well, if we can actually capture that information, we can start using some of the latest, greatest technology to actually get ahead of potential issues and disruptions and filter that back up to the user. So high-level overview of how that looks in practice. And then the last piece here, and if you want to put in the chat, I'm also curious, when we talk about AI, if you just want to put a number in from 0, 1, 2, how many different applications or use cases of AI have been deployed in your company or in your team? Maybe it's 0, maybe you're experimenting with 1 or 2, maybe it's just using ChatGPT, maybe it's using some predictive model for forecasting, but just go ahead and put in however many you're actually piloting or that you've seen in your organization. Then as you do that, we'll talk through the concept of achieving quick wins. How do we ensure that using some of these AI technologies is not going to be a 3-month, a 6-month project? It's going to be something that's very focused, and it allows us to fail fast and to learn and to iterate. So at a very high level, it involves a process of starting with basically a hypothesis. So a business case. Are we trying to get forecast accuracy up 5%? Are we trying to reduce the amount of excess inventory that we have? Whatever the case may be, we're going to set some sort of clear business criteria. Then we're going to assess how ready is our company for that. Do we have the right people in place? Do we have good enough processes that can actually use some of these technologies? And do we have the right data at our fingertips to do it? Then we'll spin up a quick proof of concept. This could be using a simple model in Excel, just as an example. It could be using out-of-the-box GPT to summarize a customer email, for example. But doing something simple that allows us to start getting user feedback from individuals on the ground floor, such as analysts, buyers, planners, all the way up to executives in the company. How do we actually start getting that initial feedback? Lastly, we want to evaluate, okay, if we were to take this proof of concept and roll it out across the entire organization or our entire function, what would be the financial impact of that implementation? So working to actually quantify that early on and then make a decision. Is it worth proceeding with this proof of concept and taking it into a full production deployment? And this entire process can take it as little as days, sometimes weeks, depending on the organization. But it allows you basically to de-risk what otherwise could be quite a lofty investment and a lengthy process. So we recommend really starting with quick wins, starting with proof of concept, starting with the minimum possible technology, and then moving into more sophistication once you've confirmed there is positive business impact. All right, with all of that said, we want to bring this down to a ground floor and really talk about what does this look like in practice, more specifically, when we're blending together all of those technologies we talked about with RPA, all the way predictive analytics, all the way to LLM. The first use case I want to highlight, and these are specific to projects that we've done out in the field, but they can be generalized to many, many different companies. And we see the 3 different use cases we'll talk about. We see these time and time again, especially heading into 2025, as we see issues around the world with geopolitical issues. We see continuous strains on supply chains, and ultimately this theme of trying to be more proactive and getting ahead of disruption. So in this case, the main challenge with supplier performance management was struggling to reliably assess suppliers' performance in real time. And a lot of the times we see that there's a reliance on fragmented data sources. So we're looking at information in our transactional systems like ERP, but oftentimes some information is siloed. We don't get it from a supplier at all, perhaps, or we only get it through email, and we're putting it together in spreadsheets, and then it's living in SharePoint. So oftentimes just getting to that real-time finger on the pulse of what are our on-time delivery rates for this supplier? What are the potential risk factors? How are the costs trending by various SKUs? All of these things are often not easy to even get to. And so we saw a challenge with that fragmented data, with the fact that there was just an overload of information, spreadsheets all over the place, and dashboards and information that really wasn't clear and condensed, and it really wasn't actionable. And then lastly, it was backward looking. So back to that theme where even getting to the point of being able to see what are cost trends with a supplier, are there delays? Oftentimes we only knew that after the event actually occurred. And so in this case, our solution really involved 3 different elements. So you'll see right here, number 1, using AI, and in this case, that was a large language model, to be able to capture some of that supplier data that was actually just coming in through emails. So alerts about delays, about contract term changes, taking all that information and being able to combine it with that transactional information they had in their ERP system. So at the crux of all of it was being able to integrate vast data sets that were disjointed. Next piece was looking at risk scoring. So building supplier scorecards that were able to continuously monitor risk factors. So geopolitical risk, bankruptcy risk of the company, risk of potential defects of the materials, whatever the case may be, but predicting the likelihood that there was going to be a delay on a purchase order that I'm going to make, or there was going to be a defect in a product. And then the last piece was the ability to generate automatic notifications and action plans if disruptions were actually detected. And so putting those all together, we were able to create a real-time dashboard that brought all that information together and was able to serve it to procurement and planning teams so that they were able to get ahead of some of those disruptions. In this case, we saw issue resolution times drastically improve, defects go down because we were able to get ahead of when there were issues with one supplier and make that tactical switch to another supplier before it actually became an issue, and ultimately reduce the days on hand because we didn't have excess inventory. We were able to make changes to production schedules as needed when a particular material wasn't in, and ultimately just operate more proactively, back to that theme. And so ultimately, this is something that we see as a tremendous need and a tremendous asset to a business that they're able to effectively manage the performance of each and every supplier proactively. And of course, as Rafe mentioned at the beginning, any questions on these use cases or any thoughts, feel free to put those in the chat, and we'll of course revisit them at the end as we get into more of a open Q&A. The second use case I want to talk about is around demand sensing and replenishment of inventory. And so in this case, the challenge we see quite a bit is struggling to order the right quantities at the right time, knowing when to place a PO, and oftentimes without the ability to sense demand at a very granular level, one of two things happens. We either put a very large buffer and our safety stock levels are set very high so that we ensure we don't have stockouts, we're not disappointing customers, but at the end of the day, we're paying to keep all that inventory on hand. So oftentimes that's a very high holding cost that we're paying. Of course, this is industry dependent, but in many cases, that's quite a large expense. And then on the other side, if we try to do just in time, or we try to be a little bit more aggressive with our inventory, then inevitably we're going to have instances of stockouts that may lead to downtime on our facilities. It may lead to customer complaints and ultimately deterioration of customer satisfaction. So we did see that in this case where safety stock levels were set more from a shoot from the hip mentality rather than using analytical methods to actually sense those changes in demand or those issues with suppliers. We saw those decisions being made reactively again. So oftentimes demand shock really didn't react to it until it had already run its course through the system and the damage was really already done. And again, information overload. We had forecasts in an Excel document, and then we have supplier information over in our ERP, and then we have our production schedule. And so we really just have this disjointed array of reports and spreadsheets, and making sense of it all was really a very time-consuming process. Though in this case, we're actually bringing together a few different technologies. Number one is that demand sensing component. To know how much to order and to be able to place those orders in real time, well, we need to be able to predict demand, not just at a customer level, not just at a monthly level, but down to the SKU level. And being able to do that means we need to factor in data that may not exist inside the four walls of the organization. This is, again, likely weather data, consumer demographic information, geopolitical information, economic indicators. We actually brought all of that data together and used machine learning models to be able to look at causal patterns and trends to then forecast demand with a much higher degree of accuracy than the traditional method of simply extrapolating past trends and using a bit of a fudge factor, talking to our sales team, and really just putting it together in a less scientific way. So number one, this was allowing us to get a bit more effective with our forecast, But also back to that concept of a tight feedback loop, we were able to then input where we over on our forecast, where we under on a particular SKU, maybe we're better at some than others, feed that data back into the machine learning system so that it continuously improved over time. And that's really a key element of any of these solutions, is that we want to see continuous improvement in accuracy over time. Now, the second piece, and this sort of goes back to that first use case, which in many ways can actually be an input to this. And you see that there's a lot of interrelation between that supplier performance use case and demand sensing and replenishment, is that we also brought in supplier scorecards to understand what are the lead times for different materials, what are the prices for each specific supplier, and also how reliable are those lead times. We've certainly seen time and time again where we're getting lead times from a particular supplier and we're not 100% confident that those lead times are actually correct. And so it's another application of machine learning and statistics, is that we can look at the history of a particular supplier and be able to understand how reliable that is going to be. Now, if I understand that supplier A tells me 6 weeks, and oftentimes that actually means 10 weeks, well, then maybe I'm going to place that PO further in advance. I'm going to set my safety stock a little bit higher. But certainly I'm going to have some suppliers that are right on the money most of the time. And so I understand that I can actually be a little more aggressive with my inventory. I don't have to keep as much safety stock on hand. So taking a demand model, taking a supply model, putting it together, we actually used what we call an AI orchestrator, or an AI system that was able to make those purchase order decisions in real time, monitor performance, flag potential issues, and then place that PO. Now, in the early days of any solution like this, of course, we don't want to hand over the keys to the castle completely to AI. We want to ensure that there's human oversight. So initially, this would be more of, hey, we recommend placing this PO in this amount for these reasons. Or we think there's a high likelihood of a delay or an issue with this particular material. Perhaps you should have another supplier you consider as a backup, or you should switch suppliers. But the final decision is still made by a human, made by an expert. Over time, as you do have that feedback loop and that continuous improvement, you can start giving more and more leeway, more and more autonomy to an AI system as it becomes more and more effective, and you become more confident in its output. So this is, in many ways, an interesting use case in that it does combine some technologies we've seen before, like demand forecasting with supplier analytics, but then the concept of auto ordering actually starts getting into more of that world of AI agents and truly autonomous systems. Now, the impact in this case, we saw an improvement again in that SKU level forecast accuracy, vast reduction in manual analysis time, because now forecasts were actually done by a machine learning system and essentially automated, beyond, of course, keeping that human oversight, but that manual in the weeds work was effectively automated. And then ultimately, the biggest business impact, we were able to reduce holding costs by a significant amount because we were more active. We were able to be tighter, more agile with our safety stock levels and have those set automatically based on the signals we were getting from the market on the demand side, and of course, factoring in those constraints we might have on the supply side. All right, and now the third and final use case we'll talk about specifically, and we do have a demo I'll go through in a minute, is on PO tracking and management. So actually managing the life cycle of, once I've placed a purchase order or I'm about to place a purchase order, I want a finger on the pulse of understanding on a daily basis, is there going to be a delay? Is there a potential issue that I'm going to have to correct for? Is that going to affect how my production schedule is going to be created? Does that mean I have to send out a notification to a customer to get ahead of a potential issue before they spot it and start emailing my customer service team? So the challenge in this case was a bit more specific than the other two, but organizations struggling to track that status of thousands of different POs in real time. And in this case, it was a food and beverage company. So we had that added challenge too of perishable inventory, that if there's going to be a delay, if there's going to be an issue with one of my core input ingredients, I might end up losing an entire batch. I might actually end up completely having that inventory go to waste. So the ability to really get ahead of delays was very, very important in this case. So we saw that PO tracking in this case was actually done manually. Information was gathered from taking tracking numbers that our suppliers gave us through EDI, then looking through FedEx and UPS and some of the other carriers on websites like trackandtrace.com and other data sources, having to manually pull that all together into an Excel spreadsheet and manage that as a procurement team. And naturally, that takes a lot of time. And humans, of course, are not perfect. There's going to be some issues every once in a while, and really inhibited the ability to track in real time what was happening with each and every PO. Lastly, those delays created production downtime. As we all know, in a manufacturing environment, downtime is incredibly costly, one of the larger labor expenses that we may have. And having those delays and those shortages and not being able to get ahead of them often created a lot of incidents of downtime. So now I will pop my screen over to another window here. Rafe, Toby, you guys able to see this just fine?
Yes, we
Yep.
are.
Absolutely.
Okay, awesome. So here you're seeing a live demo of that concept we talked about of embedded intelligence. How do we have information that's proactively sent to us when we need to make decisions, rather than having to remember to go check a spreadsheet or a dashboard or a report? So again, this is in that PO management context. We're seeing a list of all my shipments in transit. This alone, of course, does give me that high-level finger on the pulse of my various carriers, my shipments, where they're going to, and delay status. But if there is a delay, I want to investigate what's actually happening there. I don't want to have to go make 3 phone calls, send 4 emails, and actually do some sort of manual analysis. I would like for that information just to be presented to me. And so here we see a nice combination of what you may be more used to with the traditional BI style dashboard on the left, specific to what the cause of that disruption was, some high-level KPIs on that shipment. And then to the right, I have an AI-generated summary that's actually trained specifically on my data. So instead of using a GPT or some model that's, of course, trained on the entire internet and it's vulnerable to the internet, I have something custom that's actually trained specifically on my data. And so I get this nice summary to understand, why was that shipment actually delayed? And I also see here that it's prompted me to inquire about other shipments that might be delayed because of the same issue, the same root cause issue. So let me click other shipments affected. Of course, you're seeing redacted data, but you're seeing here that in this case, multiple other shipments were affected by the same disruption in the Red Sea. So I'm getting some analysis that's happening behind the scenes that instead of having to do myself or my team to do and to have to report that back, I'm getting it all in the stream of this workflow. It's almost this concept of data storytelling is happening in real time here. Now I have the option to even contact that carrier, my representative there, or I can get a report on that carrier. We see that these shipments were all on the same carrier. So I'm starting to see a pattern here, starting to see a trend. And I get a quick little carrier report. I understand what's happening with their average delivery times, their shipment costs, their delays. And it's not really painting a rosy picture in this incident. It's showing that there's quite a lot of issues, quite a lot of concerning trends with the supplier. And I'm seeing some of the driving forces that our AI system is starting to pinpoint as potential root causes. And then we see a recommendation here, recommend looking at other suppliers in our supplier base. We're seeing that this is not really a one-off delay. This is actually more of a pervasive issue. And to avoid downtime and to get ahead of these issues, I probably want to consider backup suppliers or switching suppliers in this particular instance. I'll say, yes, I want to see a few options. And we'll see in this case, the model is actually running a trade-off analysis. So we see that it recommends switching from the carrier we're using, an ocean carrier, to an expedited air freight option. And as we know, of course, air freight is more expensive traditionally by quite a bit compared to ocean, but I have so many incidents of delays and they're the same carrier behind them. So in this case, it actually does make sense from a return on investment perspective to switch from that ocean carrier to the air carrier. And we even see a projected ROI here. And then lastly, I get the option for it to email me an action plan of, hey, what are the things that we think you should actually look at? And so in this case, again, it's not like AI is making all these decisions for me, but it's doing analysis for me. It's coming up with recommendations, potential conclusions, and sourcing them to me, providing them to me exactly when and where I need them in the context of this decision I'm currently making with respect to POs. And in this case, when we think back to earlier in the slides where I mentioned that AI is often that umbrella term, in this case, we are using some elements of traditional analytics and reporting, as you see here on the left. We are using some elements of generative AI and LLMs to actually come up with these great summaries. And we're also using elements of predictive analytics to understand what the potential trade-offs and the ROI might actually be of making a decision like this. So oftentimes it actually takes a few different technologies working together in harmony to come up with a great solution like you're seeing. And then lastly, there is the ability to have essentially a custom configured chat interface as well. So if I'm not going through a specific story where I'm looking into the root cause of a delay in this case, maybe I just want to ask a specific question around the status of a particular shipment, or I want to say, hey, run me a quick report on carrier 123. How are their costs trending? Maybe I want to do a purchase price variance analysis real quick. And I do have that option in an interface like this as well. So let me bring us back to the slides. And in this case, huge impact, as you just saw in that demo, is that instead of going and manually tracking a lot of these POs, that entire process was automated. So not only was I spending less time having analysts, buyers, and planners actually doing all of this work, well, now they were able to elevate themselves to be more strategic, to help maybe our strategic sourcing team find that alternate supplier, or to have a higher touch relationship with those suppliers where now I can spend more time and actually get on the phone, or I can think more strategically through my contract negotiation, all because I'm not spending so much time finding data and analyzing data and munging data. So 3 use cases we're seeing that really impact that upstream part of the supply chain. Of course, they touch on finance from a performance management perspective, but certainly they're very focused around that procurement function, whether it's supplier performance, whether it's being able to sense demand and place those POs at the right time, or it's able just to track POs throughout their life cycle. All right, so that is essentially all the material I had prepared today. I know we went in a few different directions, brought it back down to a couple use cases that we're seeing. Certainly there are other ones, and we do have some materials on the top finance AI use cases that we have actually deployed and seen be successful. Likewise with supply chain use cases and also quick start guide. So of course, feel free to contact me if you're interested in either a copy of these slides, we're happy to send those over, or you'd like a copy of one of these ebooks to understand, what use cases are out there that we're seeing that might be interesting for your organization. So feel free to shoot that out, and then we will now open it up for Q&A, open questions.
Well, thank you, Chris. That was definitely a very exciting, informative presentation. I think it's given us all a lot to think about. One question that I think is on everybody's mind is, can I get a copy of the slides, or how do I get a copy of the slides? And if you are interested in that, please contact Chris directly, and his email is on the slide here. So we do have a couple other questions. One is, if you're a small, medium-sized business, how do you know if and when your organization is ready for AI?
That's a great question, one we hear quite a lot. And it makes a lot of sense because you don't have all of the resources in the world to hire a bunch of AI engineers or to go buy some SaaS product out there. Now, The high level answer is that every organization is ready, but to an extent. And this goes back to that concept of rapid prototyping or achieving those quick wins through proof of concepts. And so for me, we usually ask two main questions around where should I use AI. Number one is there information in my day-to-day that I need to make the decisions that I need to make that I'm not getting? Whether it's because that data, we don't even have access to it, or maybe I'm getting reports from IT or from finance or from one of my analysts, but I don't necessarily think it's complete, or I don't fully trust the data, or maybe I'm trying to predict a particular factor that I can't. So really comes down to, is there information that I'm not getting at all? That's one thing. And then the second factor is, am I spending a lot of time in my day-to-day work doing things that I don't feel like are the best use of my time? Am I spending time going and fetching data? Am I spending time interpreting reports, finding reports, sending a lot of emails? Those types of repetitive, less strategic work are also sort of trigger points for the use of AI. So for us, I would recommend, if the answer is yes to either of those, if there is an area where you say, I don't have information that I'd love to have, or I'm spending all this time in the weeds here where I'd rather be thinking a bit more strategically and working collaboratively with my team, pick a goal, pick a particular process or an area, and then start looking at easy ways to pilot AI solutions. Sometimes it's as easy as using GPT as a testing ground, right? There's no sense in building a custom model until I know that, well, what I'm trying to do is even possible. So look at using GPT, look at using some of the low code, no code solutions that are out there. And certainly I put my email in the chat if you're interested in hearing what some of those tools are that are very affordable to get started with. I can certainly help you out. But long-winded way to say that I think most organizations are ready to some degree, but to know how much you should be investing really comes down to asking yourselves those questions of where should it be applied, and then starting small before you bite off a large engagement or a large project.
Another question related to your mention of GPT is, what are the risks associated with using generative AI?
Great question. And when we hear generative AI, of course, usually we're thinking about LLMs, large language models, which would include GPT's models. It would include Anthropic's Claude series models, Google Gemini, the Llama models. All of those are LLMs. And one of the risks we always hear about is hallucination. And you may have tried this. If you go into GPT and you ask, who is Chris Andrassy? Who is Rafe Lawson? Sometimes you'll get some answers that may not be quite true. You might get that, hey, you won a Nobel Prize, and maybe you didn't do that. And so you're definitely going to get information back that is not always correct. And the way we recommend mitigating that is actually giving that model sufficient context. So grounding that model in your own business's data, so that it's not able to just go out to the general internet and fetch an answer it thinks is right. Well, no, it's going to have access to your business's data and your business's data only, so that it's not going to hallucinate answers. So I think one of the biggest risks is that it's hallucination, and that can be almost entirely mitigated by training a model on your specific data and your specific use cases and goals. The other piece is a cybersecurity risk. If we're using a public model like GPT-4o, for example, we probably don't want to be feeding it specific purchase orders and specific information about our bill of materials and all that proprietary information. Well, we don't want to just send that out to OpenAI and to Microsoft and to the broader internet. And that's an instance where we can actually use what are called open source models. We can actually download versions of these models and use them within our four walls, either on premise or within our cloud environment that we're using, to essentially air gap it, to put some space in between the analysis we're doing and the rest of the internet, so that information does not get exposed. And that is something that we're seeing companies, especially larger companies, really batten down the hatches on, of not having their employees use GPT, or at least being very careful with how they use it. Because again, if you're putting proprietary information into chatgpt.com or openai.com, well, that information is theoretically now accessible by anybody on the internet. So that's another area to be careful about.
Well, it's certainly something to keep in mind using those models. So we have another question. do you see a stronger business case and more focused AI where a business manager or analyst has a specific use case and uses the agent to try and retrieve information on that specific use case? Or a more general, quote, scan all my data and tell me where the outliers are, unquote, use case? And if the latter, do you see a lot of manual review of outliers where the data is just incorrect?
That's a really great question. Now, I tend to see that the former is typically better just because you can put some guardrails around what data I actually want to be looking at and what data I want to feed into the model. So if my use case is specifically around, we go back purchase price variance analysis, or it's financial forecasting, or it's supplier performance management, or it's contract negotiation, typically starting somewhere that's focused is ideal because now I've really narrowed the whole world of data that I want to be considering. And I can make sure that I'm using trusted data sources, data is accurate, my goals are clearly understood by the AI system, and then I can start benchmarking how successful is this, how valuable is this to my company. So typically it's the former, but the latter does have some value in specific contexts. And where we've actually done work with a trucking customer of ours is on anomaly detection of a general ledger. So looking at a rolled up view of the entire GL of the organization and effectively scanning it for anomalies, anomalous transactions. And we do see that that can be an interesting use case where you're flagging things that may not be readily apparent to the human eye. And then you've got a human team that now has almost a compass where the AI says, hey, maybe look at these 3 transactions. And then now my human team, my internal team can go look and actually investigate what the cause might be. So we do see if it's focused, if we're saying, look at GL transactions or look at POs, I've again sort of narrowed the potential universe of data that I'm looking at with the AI system. And then I can sort of let it roam free, if you will, and look through anomalies. I think there was one last part to that question on, do you see a lot of manual review of outliers where the data is incorrect? And that really goes back to the idea of the feedback loop. The first time you deploy a model like this, likely there will be some false positives or some false negatives and you'll have to review. But over time, as you're able to give that feedback back to the AI model and say, hey, actually, this wasn't anomalous. Like actually fuel prices are just increasing and so we're paying more. That's normal. Check mark. Well, now the system knows when it sees a similar transaction that, hey, don't actually flag this. This is a false positive. So over time, that's really the power of adaptive learning of these systems is that, yeah, on day 1, they're not going to be perfectly accurate. We're going to need that human in the loop. But on day 180, 1 year into this, we'll be at the point of 95+% accuracy in an ideal world where we don't have to do as much monitoring.
Great. So there's one last question, and I think it's perhaps on top of mind now for all of us who've been on this webinar and see the value in employing AI. And it's, what is typically the investment required to start seeing benefits in the use cases you highlighted today?
That's also a fantastic question. So for any of those 3, the answer, of course, the consulting answer is it depends. But the good part is typically it can be as little as several weeks and as little as not adding anybody to your team to at least get started. And again, it really starts back to understanding what is that key outcome I want to go after, and then working backwards and saying, hey, what data do I already have that might live in a spreadsheet or a SharePoint or an email or a dashboard that actually can help me start solving this problem? And then once I have that inventory of, hey, what do I have at my disposal? Then I can look at, hey, what data don't I have? And maybe go back to the example of if I'm trying to forecast demand at a SKU level, I have historical sales analysis. I have what my sales team is telling me about a particular client and what their demand is going to be. But maybe I just have no concept of weather information. If I could only bring in snowfall at a particular location, well, that's actually going to help me forecast better. So it really comes down to starting small, understanding the clear objective, inventorying the data you already have, and then taking incremental steps to move forward. But that's a question we get a lot, and yeah, happy to discuss if anybody's interested offline of, in your particular business and your particular use case you're interested in, what would it actually take to start moving the needle forward? But often it's less than people think. I think that's the big takeaway.
Great. Thank you, Chris. And thank you for that amazing presentation and discussion of those use cases. I think we all found them very useful and helpful. I wanted to mention everyone to keep an eye on our PACE channel on LinkedIn for other webinars in our series. I encourage you to sign up for our newsletter so you know details of forthcoming webinars and who's speaking and when. Thanks everybody for attending and participating in this webinar. I encourage everyone who's not already a member to become one. It's free. You get information again on our webinars, our podcasts, articles, ebooks, and there's so many other additional resources that PACE offers. So I encourage you to go to profitability-analytics.com and sign up today.
Thank you, Rafe and Toby, again for having me today. It's been really awesome to be able to speak to everybody and hope to speak to some of you afterwards.